Welcome to this course, led by trainer Rashmi Shah from QuickTechie. The Machine Learning System Fundamentals, Straight to the Brain, was created to solve a core problem. Most ML learning resources overwhelm instead of clarify. The goal here is different. We focus on internalizing mental models that last. The purpose is to make the learner feel confident in understanding how machine learning systems function end to end. Not at the superficial level where terms sound familiar, but at a level where concepts can be recalled without hesitation. We emphasize clarity, repetition, and conceptual grouping. Each concept is visualized, explained with reasoning, and mapped to real-world system workflows. The course is intentionally structured for learners who come from different backgrounds, such as software engineering, DevOps, QA, product management, support engineering, or solution architecture. Modern organizations increasingly rely on data-driven and intelligent systems. Understanding ML system fundamentals is no longer optional. When we say straight to the brain, we mean eliminating cognitive noise. No unnecessary mathematical detours. No memorization-heavy structures. Instead, we reinforce conceptual models using structure, flow, cause and effect reasoning, and relatable problem scenarios. The objective is to ensure that when you encounter ML discussions in real life, system design, trade-offs, evaluation, deployment, monitoring, you do not feel lost. You feel prepared. Visualization is not decoration. It is cognition. The human mind understands relationships, patterns, and abstractions better when they are visual. If we only read text descriptions or listen to verbal explanations, we often forget the reasoning chain that holds the ideas together. This course is structured around visual frames, sequence diagrams, system blocks, data pathways, iteration loops, lifecycle cycles, decision-making matrices, and feedback loops. These images act as anchors in memory. When a learner recalls a concept later, the visual structure provides the reference point from which meaning arises. This approach is critical in machine learning systems because ML workflows are not linear. They involve feedback loops, decentralization of logic, continuous monitoring, iterative refinement, and alignment between evolving data and evolving model behavior. Without visual reasoning, the entire system appears abstract and confusing. By grounding every idea in a visual form, we ensure the learner retains deep, durable understanding. This is the key to straight-to-the-brain learning. This learning program is not a single-format course. It is a complete learning system. The short module structure ensures that progress is consistent without exhaustion. Instead of large one-hour blocks, each lesson is structured as a small knowledge capsule. This supports habit-based learning, which is far more sustainable and effective. The companion ebook mirrors the course visuals. It is designed for repeated review so that concepts are reinforced over time. The reason reinforcement matters is that machine learning involves overlapping, interdependent ideas. Revisiting diagrams allows the learner to gradually strengthen connections. Arguments and discussion audios intentionally introduce trade-offs, disagreements, and reasoning frameworks. Real technical decision-making is about weighing alternatives, not memorizing definitions. Finally, the 4-week learning structure guides learners in pacing themselves effectively. This ensures progression without burnout, allowing concepts to be internalized slowly and strongly. Machine learning systems are not isolated to data science teams. The moment a model leaves a notebook and enters reality, it becomes a system. A system involves data pipelines, reliability processes, workflows, monitoring layers, failure handling, and collaboration across disciplines. Software engineers must understand ML system fundamentals to build features that depend on data behavior. DevOps engineers are responsible for system scaling, model-serving infrastructure, observability, and deployment orchestration. QA engineers must validate outputs that cannot be expected deterministically, but instead vary based on statistical outcomes. This changes how testing must be approached. Product owners, architects, and team leads must understand feasibility boundaries, what ML can do, what it should not do, how long cycles take, what risks exist, and what failure looks like in real-world conditions. This course ensures that each of these roles has the conceptual language and understanding to collaborate effectively, without confusion or misalignment. Learners completing this course gain a foundational competence that applies across industries and architectures. The emphasis is not on algorithms or tuning techniques. Instead, the goal is to develop a reliable understanding of how ML systems behave end-to-end. You gain the ability to translate business needs into ML problem structures. This is valuable because ML cannot solve a problem that is framed incorrectly. You learn how data flows through pipelines, batch systems, streaming systems, query-driven systems, and live inference services. You develop understanding of how features are designed, improved, normalized, encoded, and monitored. You learn why labeling strategies matter deeply, and how model results can be misleading without proper evaluation. Finally, you learn that ML systems require continuous evolution. Monitoring, drift detection, retraining, shadow deployments, controlled rollouts, and update cycles are standard practice. With this foundation, you are prepared for real-world system implementation. Straight to the brain is not a slogan, it is a learning method. This method recognizes that technical understanding develops through patterns, not through raw memorization. Therefore, the course removes details that do not contribute to the conceptual skeleton. We do not avoid complexity. Instead, we sequence it. When the learner sees the structure first, additional layers become easier to understand. By the time we reach advanced workflows, the foundation is already deeply internalized. Repetition is intentional, not identical repetition, but conceptual reinforcement from different angles. When a concept reappears later, it is seen in a new context, creating stronger neural pathways for recall. The result is that the learner does not merely remember the content, they think differently afterwards. This is true conceptual learning. This course rewards slow, steady learning. Rushing reduces retention. Instead, you are encouraged to watch a few modules each day and reflect on the visual concepts. The ebook is a reinforcement tool. Looking at the same diagrams weeks later leads to deeper clarity than the first time. Reasoning audios introduce real-world decision conflicts, why a trade-off was made, what would have gone wrong otherwise, and what reasoning frameworks apply. This is invaluable to becoming a technically confident contributor or leader in ML projects. Treat learning like muscle building. Repeated, small increments lead to durable growth. Avoid binge learning. Favor spaced reinforcement. Your next step is to begin. Not to memorize, not to rush, but to meaningfully internalize how machine learning systems work. This course is designed to change your perspective, strengthen your reasoning, and elevate your ability to participate in modern technical work. Once you enroll and follow the structured weekly plan, your conceptual foundation will grow naturally. You will find yourself explaining ML system workflows clearly. You will feel confident in cross-team discussions. You will recognize ML system behavior patterns instantly. You are not just learning a topic, you are upgrading how your mind structures technical understanding.